Well, good morning, everyone. Welcome to our presentation on respiratory protection. We're joined by Stacy Richardson, who is with 3M. She's going to give us a little bit more of a deep dive into respirators. But before we do that, let's do some quick introductions, and then we'll jump right into it. So my name is Chuck Franklin. I'm the director of EHS Managed Services here with Arbill. I've got a little over 28 years in EHS over my career. Most of my career has been in the poultry industry, and I've done a lot of startups here recently. And in my most recent experience, have worked with companies to help them build their safety structure from the ground up. Also working with cultures. And but to tell you a little bit about Arbill, we bring a holistic safety care solution to the table. And what that does is that helps companies be able to, or maybe smaller companies that don't have safety representation, be able to build a safety structure, whether that's written programs, training, inspections, record keeping, all of those sort of things. We also provide site assessments to help people see where maybe they have gaps in compliance, and also just to help them fill those gaps as well. And then we also have an environmental side to help folks with that side as far as regulations, permits, and compliance. Lastly, we have an array of training materials, and we can do training both on site and virtually. So that's just a little bit, just a quick blurb about EH Managed Services and what Arbill can help you with. But I'm gonna go ahead and I'm gonna introduce Stacy. And Stacy, tell us a little bit about yourself and your time with 3M.
Sure. Thanks, Chuck. So I have been with 3M for about 20 years. As you probably can tell, how I said about, I am actually based out of London, Ontario, Canada. But my role at 3M covers US and Canada technical service for our respiratory products, our head, eye, and face products, and fit testing. So my background education is industrial hygiene, and I have my certified registered safety professional designation from Canada. So that's me.
All right. Well, good deal. Well, thanks, Stacy. And we'll just kind of jump right into the presentation. And first thing we're going to do is we're going to cover history requirements and regulations. So kind of brings us through a quick array of things. So the first thing we want to talk about is personal protective equipment. And everybody understands the hierarchy of controls. Elimination, that's our first step to be able to try to actually eliminate the physical hazard. Substitution, engineering controls, administrative controls, and of course where we come in with respiratory protection is PPE. And of course that's our least effective, and but that is there to protect the actual employee. And now let's talk a little bit about the history, and going all the way back to 2379 AD, animal bladders were used. Bringing us into the 1500s, wetted rags, 1800s, firefighters, smoke masks, and then of course in the world wars we had chemical warfare and pandemic flu, which is where our full face respirators and all that came to be and came into production. So jumping into the regulations, I think the main thing that we want to focus on is because the most common route of exposure for our employees is the inhalation of particulates and chemicals. So, we want to make sure that, that they're protected in whatever ways that we recognize that hazard and we find out what that is and find the right protection for them. Inhalation usually is typically it's the quickest, usually causes the quickest onset of symptoms, but to mitigate those, OSHA came up with the Respiratory Protection Program. That's kind of where we're at today. So with that said, their respiratory protection standard covers many different levels, and the engineering controls is one of those, environmental controls. They've given us the permissible exposure limits, but also covering the protection for our employees. The different types that we'll be covering today, and of course I'll go over these really quickly because Stacy's going to go into more detail, but filtering face pieces, which are your dust masks, your N95s, your air purifying respirators, your APRs, and of course powered air purifying respirators, which are PAPRs, and then supplied air respirators, and lastly self-contained breathing apparatus, which are SCBAs. With that said, what are our responsibilities as an employer? And those are kind of laid out in the standard, and the basics are develop a written program, make sure we're conducting our evaluations, determine the hazardous environments, identifying the proper respirators for the environments that we're putting our employees in, and providing respiratory protection and the equipment that is proper, and make sure that we're fit tested and that we'll give them the proper training. Now, on the flip side of that, the employee, what is their responsibility? And of course, their responsibility is to follow the written program, but also to follow the maintenance inspections that we have for those respirators. It's so important that they keep them clean, that they put them in some sort of pouch or sealed, and keep them sealed until the next use. And of course, if something else shows up in the workplace, let the employer know of those new hazards or new issues. And of course, the written respiratory protection plan, it is very, very detailed. And we've got medical evaluations. It covers our procedures, fit testing, proper use of respirators, inspection and maintenance, and of course, what are those training requirements. Now, the annual respiratory protection requirements, of course, or the questionnaires, making sure the medical qualifications in place, and then making sure that we do our fit test when required, and then lastly, being sure that we do that annual training. Now, for that training, that includes a lot of things, as we all know. Of course, we've got the regulatory requirements, and then we've got to make sure that we've got the proper selection for whatever we have in the workplace. And of course, inspection and maintenance, being sure that we're following up on that, doing our monthly inspections, being sure that the employees are taken care of, that the respirators are sealed and clean after every use. All right. Well, I'll tell you what, Stacy, I'm going to hand it over to you and kind of let you take over and go in a little bit more depth.
Perfect. Sounds good. Thanks, Chuck. So I think what we really wanted to kind of do today is just highlight a few things that what we find, or in my role, I find that people tend to miss when it comes to respiratory protection programs, and we're going to highlight a few of those things. So if you want to go to the next slide, next one, you can pass out that good stuff. There we go. So, there we go. So the first thing you got to do is to figure out if respirators are actually needed, and we'll talk a bit about that in a second, and then we'll cover the parts of a program. I will review face coverings, masks, and respirators, because I feel like that should be reviewed in every single training that I do when I talk about respirators. We will touch on the regulations, because Chuck already touched on those, but specific to respiratory protection and fit testing, and then a little bit about how to select respirators. So go to the next slide. So when you do your hazard assessment, specifically for respiratory protection, we always like to point out a few things. First of all, concentration is really important. Doing air sampling, understanding what your concentration is, and what that concentration tells us is, first of all, what type of respirator you need, and also what level of respiratory protection you need. And I'll talk a little bit more about that in a bit. And it also will give you the information you need to determine how long your cartridges will last. Physical state is really important, because again, that tells you what you're going to attach to your respirator, whether it's a filter or a cartridge. Routes of entry is important. For instance, if there's something that can be easily absorbed through your eyes, you might want to go with a full face or a half face with goggles versus just regular safety eyewear. And then there's always those specific substance regulations for like silica, asbestos, all those kind of things. And then, of course, your occupational exposure limits. When you're doing a hazard assessment, you have to do air sampling, and then you have to determine if it's over an exposure limit. And if it is over an exposure limit or near an exposure limit, then you're going to move to using respiratory protection. All right, next slide. So when you look at this, I know there's a lot of smaller, medium companies that get overwhelmed by this. So we always like to suggest, there's lots of consulting services out there that can help with these things. And in order to, once you know what you're dealing with and the levels that you're working with and dealing with, you can understand how to reduce those exposures. And Chuck talked about the hierarchy of controls. That's kind of our rule book for industrial hygiene. You always try to eliminate, substitute a hazard out. And then if that's not going to be enough, you can look at engineering controls, and finally PPE. Next slide. So if you get to the point where you have to wear respiratory protection, you need a respiratory protection program. And all the parts of this you see here, this is parts of a program. And it's really important to understand that you need a written program. In our experience at 3M, what we do find is if a regulator comes on site and they see people with respiratory protection on, they're going to ask to see your written program, and they're also most likely, if it's tight-fitting respirators, they're going to ask to see your fit testing documents. Those are the two most common ones. So don't forget you need a full written program that covers all these parts. All right, next slide. So we talked a little bit about regulations before. I always like to just kind of bring it all together. Obviously, your workplace, you need a respiratory protection program if you're using respirators. And then what feeds into that is OSHA actually tells you what parts of the program need to go where. So, and what details you need in each of those parts of the program. Where NIOSH fits in, and NIOSH is a branch of the CDC, they certify respiratory protection. So in North America, we are required to use NIOSH-approved products. So for instance, if 3M was to come up with a new respirator and we want it certified, we would submit it to NIOSH, and they would actually test it to make sure it works the way we're claiming it to work, and then therefore give it a certification. All right, next slide. All right, so this one here, I always like to review this. There's a lot going on here. I'm not going to go into a lot of detail, but I always like to point out the difference between a mask and a respirator. So if you looked at those first three columns, those are all different types of masks, whether it's your homemade face coverings. We saw lots of those during COVID. Procedure mask, you might find that like a dental office, or a surgical mask, which you're going to find in a healthcare setting. They're all loose fitting. Now, a surgical mask might have a few more testing to it, like flame resistance and fluid resistance, but they're all loose fitting. And because they're loose fitting, they're not actually providing you with any protection. The whole point of a mask is to stop large particles from your nose and mouth exiting and getting too far. So it's meant to actually help people around you, not yourself. Versus when you get to respiratory protection, that fourth column there, our first category, filtering face piece respirators, now it's tight fitting, and now you're actually filtering your air and you're wearing it to protect yourself. So those are that's the big difference between a mask and a respirator. Now, filtering face piece respirators, they're tight fitting. They're only good for particulate protection. We'll talk a little bit more about that in a second. But then you could move to your reusable respirators, which would allow you to have a half or a full face. And then that also allows you to have different things attached to it so that you can use it for different hazards. And now you're looking at cleaning, maintenance, and storage because it's a reusable type respirator. And then finally, that PAPR, powered air purifying respirator. And in this picture specifically, it's a loose fitting head top we're talking about. And the point I want to show here is if you ever see anything that says tight fitting, that would require a fit test. If it says loose fitting, it does not require a fit test, and you are not able to actually perform a fit test on it. All right, next slide. So when we always like to review, the philosophy of respiratory protection is to actually reduce your exposures on the inside of a respirator versus the outside to a safe, acceptable level. And that's only going to be achieved if you're using the right products, if you're fit tested on a tight fitting respirator specifically, and if you're wearing it properly. All right, next slide. So what are the most common types of respiratory protection program that people overlook, the parts of it? Yep, next slide. So this is, again, just to review, this is right from OSHA, and the standard for respiratory protection is that 1910.134, and it lists all these different sections of the program. And the parts of the program that most people miss, and we'll talk a little bit more about, is voluntary use is a little misunderstood. The medical surveillance or medical evaluation is something that a lot of people get confused or just miss completely. So those are the two ones we'll talk about, and we're also going to speak about fit testing as well. All right. So medical evaluation. I do a lot of training, and we talk about medical evaluation in that training, and it's one of those things that's not well understood. It is a requirement of the actual respiratory regulation. And the whole point of it is to make sure that someone is able to wear the respirator they need to wear and be fit tested. So that's the general purpose. Now, what OSHA specifically says is that it must be performed by a physician or other licensed healthcare professional. And it needs to be completed on all mandatory users and voluntary users of a reusable respirator or other respirators other than disposable. We'll talk a little bit more about voluntary in a bit, but I always like to point out here Because it has to be performed by a licensed healthcare professional, there's lots of small to medium companies out there that don't have a medical professional on staff. Therefore, there are lots of services out there that provide this service so that you can use it, have it complete, and actually meet the standard or meet the regulation. And that's what that picture is, excuse me, of in the slide, is our specific one we have on our website. We work with a third-party company. You can go online, you get a specific password just for you, you fill it out, it's reviewed by a medical professional, and you're provided with an answer back that either says, yep, you're good to go for that respirator, or maybe, yes, you can wear that respirator, but here's your limitations, or no, we're not able to allow you to wear that respirator, and further discussion needs to be had. The interesting part about medical evaluation is under the regulation, there's no specific frequency required. It has to be done originally before you actually wear a respirator for the first time and get fit tested. But after that, it doesn't say how often. So we usually suggest to try to do it every couple of years or even every year when you have to do a fit test, because your medical conditions does change. Things will change over time, and you want to make sure that there's something that hasn't come up that could affect your ability to wear a respirator. Next slide. All right, so voluntary use. Voluntary use is basically when somebody wants to wear a respirator but doesn't actually have to. So the levels or concentrations in the air are not such that they actually are required to wear it, but they may want to. And I always give the example of when I was the industrial hygiene person in our plant. And what they did was they had a certain solvent they used in an adhesive. We make a lot of sticky stuff at 3M. And it was very, very, very stinky. And we did air sampling, and so much air sampling, and we realized no one's anywhere near an exposure limit. Some of the results were even close to being non-detectable. But it smelled, and the odor threshold of that chemical was so low that it would just give people headaches. So although they didn't require a respirator, we provided them with a respirator to make sure that they didn't end up with being uncomfortable with a headache or symptoms like that. So that would be an example of a voluntary use. Next slide. So under OSHA, what it is for voluntary use is that a couple different things depending on which type you're using. So if you were to just grab like a N95 disposable respirator, what the OSHA wants you to do is make sure that people are trained to the point where they can wear it properly. So minimal training, Appendix D, is basically saying they need to know how to put it on, how to take it off, and how to conduct user seal checks. Those are the basics. For reusable or elastomeric, another name for reusable is elastomeric, they want you to do a little bit more. So they want you to still go through a medical evaluation. You certainly need to be taught on how to clean, store, and maintain, because they are reusable respirators, as well as that minimal training of how to put it on, how to take it off, how to conduct your user seal checks. The other important part here is to make sure that you're not creating more of a hazard, so by wearing a respirator. So make sure that there's training involved to make so that they're clear that it's not going to create more of a hazard. The interesting part about voluntary use, OSHA does not require fit testing for tight-fitting respirators for voluntary use. But 3M will always recommend it, only because if you don't know if if you don't do a fit test, you really truly don't know if a respirator fits properly. And if you don't know if it's fitting properly, there's not a lot of a point of wearing that respirator in a contaminated area or an area where you're trying to protect yourself from something, even if it's below an occupational exposure limit. All right, next slide. So some considerations for types of respirators, and Chuck touched on these as well. It really breaks it down into three different types. You have your oxygen deficiency. So if you don't have enough oxygen in the air, you're going to need something like you see here with the SCBA, the tank on the back, or even an escape respirator hooked up to an airline, depending on what that situation is. And then really your other two big categories are your particulates and your gases and vapors. And depending on what you have in your environment, that will tell you what type of respirators you need to choose. Next slide there. So when we talk about filters versus cartridges, we always like to make it very clear that cartridges will only work for certain gases and vapors, and filters will only work for particulates. Filters will not help protect you from gases and vapors, and cartridges will not help protect you from particulates. So gases and vapors are fairly self-explanatory, but particulates are going to include your dust. Everybody knows what a dust is. Fibers like an asbestos fiber, mist. Mists are created when you use pressure to get either a liquid or a powder out into the air. So think of coughing and sneezing creates a mist. Spray painting, anything aerosol spray, that's going to create a mist. Bioaerosols are particulates. Bioaerosols would include mold, fungi, viruses, bacteria. That all fits into the bioaerosol category. And then finally, fumes. And I find people use the term fumes incorrectly. I've even caught myself actually do that, where they say, I smell gas fumes. Fumes are actually only created when you heat metal. So that would be welding, soldering, heavy-duty grinding, gouging. The majority of the time, it really truly is when you're just welding. Okay, next slide. So when we talk about filters, everybody uses NIOSH-approved products in North America. So every manufacturer has to follow the same classifications. And really, when it comes down to it, there's two kind of parts to it. You have your N, your R, and your P. And all that means is if the filter is oil resistant or not. And oil mist used to be used a lot in machine shops, things like that. It's not that common any longer. There's just different methods they use that are a little bit less harmful in terms of having to inhale oil mist. But if you do have oil mist in your environment, you need to use an R or a P class so that filter works properly. And then your minimum filter efficiency, and that's really how NIOSH tests these filters. And what they've done through different filtration theory is they've determined what the hardest size particle to filter is. And it's a little bit of a range. It's around 0.3 microns. So they'll take something like an N95 and they'll throw a whole bunch of particulate at it within that range. And they'll make sure that at least 95% of that particulate has been filtered out. So a N95 is 95% efficient against the hardest size particle to filter, versus a 100 is 99.997% efficient against the hardest size particle to filter. Next slide. So how do you know when to replace these? And we get these questions a lot. Dirty, damaged, or difficult to breathe, the 3 Ds we usually say. So certainly if it's damaged, you're not going to want to use it, throw it out. If it's dirty, it will start to increase breathing resistance, which we'll talk about here in a second. I always like to mention, if you're in a healthcare environment or you're dealing with an infectious contaminant of some sort, you're going to want to follow your infection control procedures. That might be very specific of when you're going to change those filters. But increased breathing resistance is the main way that most of our industrial customers will know when to change the filter. Because what's really cool about a filter is that if you looked at a filter underneath a microscope, you'd see a whole bunch of little fibers intertwined together. And as you breathe through it, all those little particulates are going to get trapped in those fibers. And eventually, you'll just have so much trapped in there, it's going to be harder to get your air through. And when that happens, you know to change your filter. The beautiful part about filters is that you'll never have so much captured on and through the filter that it will start to come through and expose you to it. It's just going to get harder to breathe, and that will tell you need to change your filter. Next slide. So now we're going to talk a little bit about cartridges. Next slide. So cartridges are basically like your carbon that you would find in a Brita filter, water filter, or a fish tank filter. And they basically take the carbon and they do a few things to it to create a whole bunch of little surface areas on the carbon. And I like to explain this. My coworker used this analogy, and I thought it was brilliant. Think of the carbon in a cartridge like a parking lot. And there's a whole bunch of these parking spots for these gas and vapors to absorb onto. So as you're breathing through a cartridge with the respirator, those little gas vapor molecules are absorbing in each of those parking spots. And eventually, those parking spots will be used up. And once those parking spots are used up, the gas vapor has nowhere to go, and it's going to come through into your breathing zone. So we'll talk in a second about how to replace them, but it's kind of a good way to think about how that carbon works. Next slide. And there are different types of carbon. So our organic vapor cartridge, which is your most basic, it uses just carbon. And then the other types of cartridges that you can get, like acid gas, ammonium methylamine, formaldehyde, they'll have a specific treatment to them to make sure that it is capturing that specific category of chemical. Next slide. And then, again, these are NIOSH approved cartridges, so everybody has to follow the same classifications in North America. That black one is your organic vapor. I'd say it's probably the most common. Next to that would be the multi-gas, which is like an olive color. I always say I don't understand why they chose 3 shades of green. There's a lot of different colors in the world they could have used, but this is what they came up with when they started the classification. And multi-gas is basically a layer for organic vapor, acid gas, formaldehyde, and ammonium methylamine. So the one misconception about multi-gas is that they think it will work for everything and anything. It will not. It's basically, think of it like a sandwich, and it has a layer for organic vapor, a layer for acid gas, a layer for formaldehyde, and a layer for ammonium methylamine. Next slide. So cartridges and when to change them. This is a question that comes up so often for us. And it's not an easy answer because, quite frankly, the only way you truly know when to change your cartridge is by understanding your concentration. And we have a service life software, and I'll show you that here in a second. And all major manufacturers do have something like that. But within that software, you're going to need to know your concentration, your humidity, your temperature, and your work rate. And the reason for that is all those things affect the actual cartridge life. Humidity, when we talk about organic vapor specifically, humidity is a really big deal. Because if you think about it, humidity is moisture, right? It's a water droplet in the air. And remember I said those parking spots on the carbon. Well, what happens is when you inhale a whole bunch of air with the humidity being very high, those little humidity or moisture particle or gas vapor molecules will take up a parking spot. So they end up taking up the spots where the actual gas vapor you want to absorb onto. And that what happens then is your cartridge life significantly decreases when you have a really high humidex or humidity in the air. Work rate as you're breathing. If you're huffing and puffing and you're breathing really hard, shoveling, you're going to pull more air through that cartridge, which means those parking spots are going to be taken up quicker on that carbon. So that will affect it, as well as temperature and a few other things. So just keep that in mind when you're looking at your cartridges in your service life. Next slide. So I always like to make a point to say that OSHA does require you to have a proper schedule. It will not allow you to rely on your taste, irritation, or odor to know when to change a cartridge. Now, if you had a cartridge, a service life calculation of 10 hours and at 8 hours you have taste, irritation, or odor, by all means you need to change it. But they don't want you to rely solely on that. And that means that you do need to understand your concentrations to do a proper calculation on how long that cartridge will last. Next slide. And this is just a screenshot of what ours looks like. It's available to anybody. You just go to Google and Google 3M Service Life Software, and this will pop up. And I think it asks you for your email address, but besides that, it gives you all the information. That it's very easy, step by step. You can put in all your chemicals, you put in all your data, and it gives you a really nice report at the end with your estimated service life on it. Next slide. So when we talk about types of respirators, and Chuck had mentioned this earlier, I always like to review the fact that, when we see air purifying, it really means that you're using the air that already exists and you're cleaning it somehow. So if you were to look at disposable and reusable respirators, the difference between them and powered air is they use your lungs to function. So a disposable and a reusable product, you're pulling the air through yourself through a filter, cartridge, or a combination, and then it's clean on the other side. Versus powered air, it does the work for you. So it has a little battery and a blower and a filter cartridge combo, whatever you need, pulls the air through for you, delivers your clean air through a breathing tube into a head top or a face piece, but they're still all using the air that exists already. Versus supplied air, you're getting air from another source, whether it's from an airline that hooks up to an air panel from a compressor or your tank on your back, self-contained breathing apparatus. Next slide. So one thing that we find a lot of people don't understand is they might choose the right respirator in terms of, do you need a filter, do you need a cartridge, do you need both? But they don't understand the level that they need. And the level I mean is their assigned protection factor. And OSHA has its own assigned protection factors. You see them there. And what that means is something like a half-face respirator has an assigned protection factor of 10. And that means you can use that respirator in a concentration up to 10 times what you're allowed to be exposed to. And then if you go beyond that, you need to get a higher level of protection. Again, this means you need to know your concentrations. You need to know what you're exposed to compared to the exposure limit. And if it's 10 times more than that, then you're going to need something with a higher level of protection. And as you see, full face with a quantitative fit test goes up to 50. Powered air purifying respirator with a certain type of head top and hood will either be 25 or 1,000, depending on that head top. And then your highest level is your self-contained breathing apparatus, which gives you an assigned protection factor of 10,000. Next slide. So let's talk quickly about fit testing. You see here, everything circled there does require a fit test. So like I mentioned earlier, anything that is tight fitting would require a fit test. And even something like a full face respirator that's used with supplied air, that will still require a fit test first in negative pressure mode before you use it with supplied air. Next slide. Okay, so how many are required to participate in fit testing? Okay, keep going. Perfect, thanks, Chuck. So fit testing, anybody wearing a tight fitting respirator has to be fit tested, right? So, and that goes for even your good old, N95s. A lot of people still don't realize these are disposable respirators. They are a respirator. They are tight fitting. They do need a fit test. There are different methods approved under the OSHA regulation. There's qualitative, which really is a subjective test. It's going to rely on somebody's ability to smell, taste, or have irritation. And then there's quantitative, which are more like a machine that you're going to hook the person up to. Well, they do different breathing exercises, and both of these methods are going to determine the seal based on the different movements and breathing exercises. The whole point of a fit test, yeah, you're okay, Chuck. The whole point of a fit test is to make sure that make, model, size fits you. Now, the reason I have this slide here is because the biggest problem with tight-fitting respirators is interference concerns. And those interferences will make the respirator not fit properly. And our biggest problem is facial hair. So what this slide is showing, and I love this slide because it's a good visual to show that there's a lot of stuff that you can't see with your naked eye. And one of the things I do get commonly told is, oh, I don't need a respirator. I can't see anything in the air. Well, this slide just shows you there's a whole lot of things that you can't see that you're still going to breathe in and can still harm you. And not only that, look at the size of those particulates versus a facial hair. So if you think about the seal of your respirator, and if you had facial hair in that seal, what's going to happen as you try to pull air through the filter or face piece is that your air will take the path of least resistance. And that's going to be where your facial hair is, because that facial hair is going to create little canals for air to be able to flow through. So if you have facial hair in that seal and you're pulling your air through, the air will not work harder to go through the filter when it can more easily go through right where the little canals of air are open from that facial hair. It will always take the path of least resistance. So we not only say you need to be clean shaven when you're wearing a tight fitting respirator or being fit tested a tight fitting respirator, but it just makes sense. And I always say it's science. Science shows you that there's just no point of wearing a respirator if you're going to have facial hair. Okay, next slide. So there's a cool little poster that NIOSH has. I think it's fun. I've seen lots of customers put this up in their workplaces. It's a nice visual to say, okay, there's a whole lot of facial hairstyles that are not acceptable. And it really comes down to if you have any facial hair in that seal, it's going to cause a problem. Now, you could have a nice, big, bushy mustache that fits in the seal. The other thing you need to just be careful of, it's not going to interfere with any of the valves. For disposable with a valve, it's the exhalation valve. And for usables, it could be inhalation valves or exhalation valves. And one of those could get stuck open when it's not supposed to. And then that respirator is not going to do you any good in that configuration as well. Okay, next slide. All right, so let's talk a little bit about how to store our respirators and clean them properly. Okay, next slide. So when we talk about cleaning, maintenance, and storage, and this is for reusable respirators, and disposable respirators as well, you need to store them properly so when you go to use them, they're in good shape. But for reusable respirators, what we usually say is if you're wearing one, and I'll just grab one here, if you're wearing one every day, then you're going to want to make sure, at least at the end of the day, wipe it out with a respirator wipe and then put it back in the bag that it came in. That will at least give it a good amount of protection from the outside elements. The worst is when we go into a place and we see this hanging up on the wall and God knows what's gotten into it. So at least wipe it out, put it in the bag it came in, put it in a locker somewhere where it's not going to get damaged. Now, if you're wearing it quite a bit, or if you've worn it and let's say you got a cold or the flu, what you got to realize is your germs are in there, and those respirator wipes don't actually disinfect. So once in a while, you're going to want to give this a good cleaning, whether it is soaking it in bleach to water solution, soap and water, and then rinse it good with water after and let it dry, or at least a disinfecting wipe. Allow that contact time to happen, then wipe it with water and let it dry. So I do see one question. How is a respirator wipe different from alcohol? Yeah, that's a great question. So the respirator wipes generally do not have enough of the chemical in it to actually consider it a disinfectant. So it won't actually, how I see it is it won't kill anything. It's going to wipe out the dirt and the sweat and the debris, but it's not actually killing anything that's going on there. So on a day-to-day basis, if you're wearing your respirator all the time, it's usually not a big deal. You wipe out your sweat, your dirt, you're good. But if you're having to wear it and someone else is going to wear it, you certainly need to disinfect it. Or, as I mentioned, if you're wearing it frequently or you've just had a cold or flu and you don't want to reinfect yourself, disinfectant is definitely the way to go. Okay? Now, that's cleaning, maintenance. Maintenance, the one thing I'm going to mention here for maintenance, really important, couple things. Make sure before you use it that your valves are in place, inhalation valves, exhalation valves. Some face pieces have gaskets. If they do have gaskets, make sure that they're there. Make sure your straps aren't about to break, right? Make sure it's in good shape. The other thing, over time, the oils of your skin will start to warp that face piece out. So if you start to see the warping happening, make sure you change that face piece. It's time for a new one. Okay, next slide. And this, again, is just showing you this slide here that there's lots of different things. Now, I will tell you, during COVID, we had this question come up so often that we ended up putting together a great tech bulletin on cleaning and disinfecting for reusable respirators. And I'm happy to share that with you guys. I could put it in the chat here after or share it with Chuck, and he can send it out to you. It's available online still, and it has a lot more detail on it in terms of specific disinfectants that we've used, that we've tried, because the problem is there's a whole lot of disinfectants out there. And the ones that we haven't tried, we're not going to be able to guarantee that it's not going to prematurely degrade the face piece. But because of COVID, we did do a lot more testing. So there's quite a bit of results in there that show you which products we've tried and which ones did not affect our respirators. Next slide. So finally, this is just basically showing you, we have a website that's really helpful. If you're ever interested, take a look at it. It's the 3M Center for Respiratory Protection. It breaks down each of the parts of a program quite nicely. And then it also gives you some extra little details in each of these sections that might be helpful. For instance, fit testing will have the link to the video. It will also have information on our fit testing workshop that we offer virtually. It has a fit test record form. For medical evaluation, it has that link to the third party that you can set up with and use for your medical evaluation. In the written program, it gives you a template or an example of a written program. So there's lots of great tools in each of these sections if you want to take a look at that. All right, next slide. And then finally, I always like to give a shout out for our customers of our tech service line. So this is about 10, 12 individuals that all they do all day is answer questions on respiratory protection and all of our other personal safety products. So head, eye, and face, hearing, fall protection, you name it. That phone number that you see there, if they can't answer it, they'll come to someone like me, but they've done this for so long. They're so experienced. They know so much. So please feel free to reach out to them anytime you have questions on our 3M respiratory protection. And I think that was my last slide, Chuck.
Yep, that's it.